All right, today we're going to look at dividing or simplifying an expression that has division and also has exponents. And so although we could use something called the quotient rule, what we're going to do today is we're going to expand and simplify using giant ones to see how this works out. So I'm going to take the quantity 12x to the fifth y to the fourth z squared, and I'm going to divide it by the quantity 6x cubed y to the seventh z squared. Remember that between each of these variables and the coefficient is an implied multiplication, so really we're taking 12, multiplying it by x to the fifth, multiplying that by y to the fourth, and multiplying that by z squared. And then similarly in the denominator we're taking 6 times x cubed times y to the seventh times z squared. So the first thing we're going to do is we're going to expand our numerator and we're going to expand our denominator to see what we can simplify. We're going to look at first the number 12, and we're going to think about how we can expand that. And so thinking about 12 as a product, we could think of it as 6 times 2, 3 times 4, but really what we want to do is break it down to its prime factorization. So we can actually write 12 as 2 times 2 times 3, because 2 times 2 is 4, times 3 is 12. X to the fifth can be rewritten as x times x times x times x times x. Y to the fourth can be written as 4 y's being multiplied together. And then z squared is just z times z. In the denominator, we're going to expand 6 to its prime factorization. So 2 times 3 gives us 6. Then we have 3 x's being multiplied together to get x cubed. 7 y's being multiplied together to give us y to the seventh. And 2 z's being multiplied together to give us z squared. From here, what we're going to do is we're going to try to look for some giant ones to simplify this. And remember, anything divided by itself is 1. So for instance, 2 divided by 2 gives us a giant 1. 3 divided by 3 gives us a giant 1. We have 3 x's on the bottom that can make giant ones with 3 x's in the numerator. So 1, 1, and 1. 4 y's in the numerator and 4 y's in the denominator will give us giant ones. And then you'll notice these 2 z's in the numerator and the denominator give us giant ones. So in the numerator, we really have 1 times 2 times 1 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 times 1, which is just a really complicated way of saying 2. And then we have x times x, which is x squared. In the denominator, the only thing we're really left with are all these ones being multiplied together, which doesn't do anything to a value, and then y cubed. So in reality, this expression here started as 12x to the fifth y to the fourth z squared divided by 6x cubed y to the seventh z squared, and it simplifies down to 2x squared divided by y cubed. Hopefully you can start to see some shortcuts, but the nice thing is that expanding and simplifying will get you to the right answer every time.